Hello 8th graders, I am Paula Bianca P. Cruz, your virtual instructor for today. So we are now in the second week of the first quarter in Mathematics 8. The lesson is all about application of factoring to real-life problems. So at the end of the lesson, you should be able to, first, factor completely different types of polynomials, such as polynomials with common monomial factor, difference of two squares, sum and difference of two squares, sum and difference of two cubes, and perfect square trinomials and general trinomials. And number 2, you should be able to solve problems involving factoring. So before we start with examples, let's recall the different steps in solving word problems involving factoring. There are actually 5. Number 1, you should read and understand the problem. Number 2, identify the given and what is asked for. Number 3, determine which special product could be applied in the situation or problem. Step 4, solve the problem using the patterns you learned on factoring. And the last step is to check your answer. So, just what like you learned from your week 1 lesson, factoring is the reverse of multiplication. It consists of writing polynomials as product of several factors. And you learn that there are different factoring techniques, which are the following: polynomials with common monomial factor, difference of two squares, sum of two cubes, difference of two cubes, perfect square trinomials, and general trinomials. So let's explain it one by one. If you saw that the polynomials have common factor, like this one, ax plus ay, we can factor the polynomial by removing the common factor a and dividing each term by the common factor, which is x plus y. Next, for the difference of two squares, if the polynomial has exactly two terms and both terms are perfect squares and the operation involved is subtraction, like this one, minus sign, we can factor it using the pattern a plus b times a minus b, where a and b are the square roots of the first and the second term of the given polynomial. Next, for sum of two cubes, if the polynomial has exactly two terms, the operation involved is addition, and both terms are perfect cubes, we can factor it using the pattern a plus b times a squared minus ab plus b squared, where a and b are the cube root of the first term and the second term of the given polynomial. Next, for the difference of two cubes, if the polynomial has exactly two terms and the operation involved is subtraction and both terms are perfect cubes, we can factor it using the pattern a minus b times a squared plus ab plus b squared. For the perfect square trinomials, if the polynomial has exactly three terms and the first and the last term of the given polynomial are perfect squares and the middle term is just 2 times the product of the first and the second term, we can factor it using the pattern a plus b raised to the power of 2. And if the operation of the middle term is subtraction, like a squared minus 2ab plus b squared, the factor is a minus b raised to the power of 2. And for the last polynomial, general trinomials, if there are exactly three terms and we cannot apply any of the factoring techniques mentioned earlier, we can factor it by just getting the product of the last term to get whose sum is equal to the middle term. So we can elaborate this further using the different examples in your activity. So let's have some examples that are somewhat similar to the first activity of week 2 in your activity sheet. So activity 1 is entitled Let's Apply Factoring. The direction is to solve the following problems involving factoring. The first example. A lot owned by the Dalisay family at Dilan Paurido measures 5d squared minus 17d plus 6 hectares. What are the dimensions of the lot? For the solution, step 1, we have to read the problem. So what is being asked for? We must find the dimension of the lot. Note, however, that the dimension means the length and the width. Step 2. Let's identify the given and what is asked for. We know that the area is length times the width. So let L equals length and W equals width. Thus, area is equal to length times width. Now, since the area given from the problem is 5d squared minus 17d plus 6, we can say that 5d squared minus 17d plus 6, the area, is equal to L times the width, where the length and the width are both unknown. The third step is to determine which special product could be applied in the situational problem. Now, recalling the area of the rectangle, which is A equals length times width, area is 5d squared minus 17d plus 6. Going back to the different factoring techniques mentioned earlier, which factoring technique falls in the polynomial 5d squared minus 17d plus 6? It is general trinomials. There are 3 terms, but the first and the last term are not perfect squares. So we are going to apply the trial and error method, or we call general trinomials. Step 4. Solve the problem using the patterns learned on factoring. So we have the area 5d squared minus 17d plus 6. So based from the mentioned factoring techniques, this kind of polynomial falls under the general trinomial, which means that we have to find the factors, 2 binomials that when multiplied will give the answer 5d squared minus 17d plus 6. Now this kind of polynomial requires a trial and error method. How do we do that? First, we have to factor the first term. So the only factors of the 5d squared is 5d times d. Next, we have to factor the last term, positive 6. So in this situation, there are a lot of factors that we can apply. So we have to exhaust all of the factors until we arrive at the correct answer. So let's say we will use the negative 2 and the negative 3 as the factors of positive 6, because negative 2 times negative 3 equals positive 6. Now, to check if the factored form is correct, we have to multiply the means and the extremes. And after multiplying, their sum should be equal to the middle term, which is negative 17d. So the means here is the negative 2 and d, and the extremes is the 5d and negative 3. Let's start multiplying the means. Negative 2 times d equals negative 2d, plus the product of the extremes, 5d times negative 3 equals negative 15d. Again, the rule is the sum of the product of the means and the extremes of the factored form must be equal to the middle term, which is negative 17d. Now, adding negative 2d and negative 15d gives negative 17d. This implies that the factored form is now correct. So, it means that the length is equal to 5d minus 2 and the width is equal to d minus d. Let's proceed to the next step. We have to check the answer. To check, we will multiply the factored form 5d minus 2 times d minus 3 using the FOIL method, and we should arrive at the correct area, which is 5d squared minus 17d plus 6. Now, using the FOIL method, we'll multiply the first 5d times d, the outer minus 5d times 3, inner negative 2 times d, and the last negative 2 times negative 3. Simplifying, we have 5d times d equals 5d squared. Negative 5d times 3 equals negative 15d. And negative 2 times d equals negative 2d. And negative 2 times negative 3 equals positive 6. Simplifying further, we have 5d squared. Negative 15d minus 2d equals negative 17d plus 6. Since the area is correct after multiplying, therefore, the measure of the length, 5d minus 2, and the width, d minus 3, are both correct. If you understand. Therefore, we can conclude that the dimensions, or the length and the width, of the lot are 5d minus 2 and d minus 3, respectively. Let's have the next example. A square mirror is on sale at CB Mall. It has an area of 36 meters squared minus 16 meters plus 25 square units. What is the measure of its side? Step 1 is to read the problem. So we must find the measure of the side of the square. Step 2 is to identify the given and what is asked for. We know that the area of the square is equal to the square of its side. So let's say S is equal to side. Thus, A is equal to S squared. Step 3. Let's determine which product or which special product could be applied in this original problem. The formula for the area of a square as mentioned is A equals S squared. The area is given, which is 36 meters squared minus 60 m, plus 25. And the side is unknown. Now, what do you think is the factoring technique that falls under this kind of polynomial? The first, as we can observe, the polynomial is a trinomial. The first term is a perfect square, and the last term is also a perfect square. And the middle term is twice the product of the square root of the first and the last term. It falls under the perfect square trinomials, which states that a squared minus 2ab plus b squared is equal to the quantity a minus b raised to the power of 2. Again, the reason behind this is that a squared, or our a squared, is 36m squared. It is a perfect square, isn't it? And the last term, b squared, is 25, which is also a perfect square. And when we get the square root of the first and the last term, the square root of 36m squared is 6m, and the square root of 25 is 5. Multiplying 6 times 5 was 30, times 2 from the formula or the pattern, we get 60m. Therefore, this polynomial is a perfect square trinomial. So what is s squared? How do we factor it? We will just use this pattern. So solving the problem using the pattern on the general square trinomial or on the perfect square trinomial, 36m squared minus 60m plus 25 equals, we just have to get our a, which is the square root of the first term, minus b, the square root of the last term, which is 25. Square root of 36m squared equals 6m, and the square root of 25 is 5. Following the sign, minus, and raising the binomial to the power of 2, we get the complete factored form. 6m minus 5 raised to the power of 2. This implies that the side is equal to 6m minus 5. Can you follow? Now, to verify if this is correct, of course we have to check the answer. So we get the factored form 6m minus 5 squared. 6m minus 5 squared means 6m minus 5 times 6m minus 5. Applying the FOIL method, we get 6m times 6m minus 6m times 5 minus 6m times 5 minus 5 times negative 5. Multiplying, we have 36m squared minus 30m minus 30m plus 25. Y plus negative times negative is already positive. And simplifying this further, combining negative 30m minus 30m, we have 36m squared minus 60m plus 25, which is actually the area of the square meter mentioned in the problem. Therefore, the side of the square meter really measures 6m minus 5. Our answer here is correct. Let's have another example. A garden located at Sunflower Maze Tayog Park has an area of 144 s squared minus 100 square meters. What is the measure of its sides? Step 1. Reading the problem, we learned that we must find the measure of the side of the square. Step 2. Identifying the given and identifying what is being asked for. We know that the area is length times width. So let L be the length and W be the width in meters. Thus, area, or A, is equal to length times width, or L times W. Step 3. Let's determine which special product could be applied in the situation or problem. The formula for the area of a rectangle is A is equal to L times W. The area given is 144 s squared minus 100. We are looking for the length and the width. What do you think is the best special product or the factoring technique that falls under the polynomial 144 s squared minus 100? First, we can see that the given polynomial is a binomial. It only has two terms. And we can see further that both terms are perfect squares. 144 s squared is a perfect square, may square root pa. And 100 is also a perfect square, may square root pa. And the operation involved is subtraction because of the minus sign. Therefore, this polynomial falls under the difference of two squares, which states that a squared minus b squared is equal to the quantity a plus b times the quantity A minus B, where A and B are the square roots of the first and the second term. So what could be the length and the width? Proceeding to step 4, let's solve the problem using the pattern learned on factoring. So, applying the difference of two squares, we get A first. Let's get A. A is just the square root of the first term. What is the square root of 144s squared? It's 12s. And let's get B, the square root of the second term, which is 100, and the square root of 100 is 10. So we got these numbers from the given alone. And following the pattern, after getting A and B, the first binomial must be a sum, and the second binomial must be a difference. So the correct factored form is 12s minus 10 times 12s plus 10. We can interchange the two binomials since the product, the operation involved is multiplying. Pwedeng magkabaliktad yan. This implies that L is equal to 12s minus 10 meters and W equals 12s plus 10 meters. And let's check the answer through the FOIL method. Applying the FOIL method, so proceeding with the process, we got to learn that the answer is correct because after multiplying the factored form through the FOIL method, we get the same area, which is 144s squared minus 100. Thus, the side of the garden measures 12s minus 10 meters and 12s plus 10 meters.
This virtual instruction couldn't be possible without the concerted efforts of the following members of the grade 8 team. We have Sir Nancy Ancheta, Ma'am Reyna S. Corpus, Ma'am Ofelia B. Matatak, Ma'am Rowena V. Palamin, Ma'am Mary Gracie Talvo, and yours truly, Paula Blanca P. Cruz.